So I'm going to talk about cardiac action potential. So cardiac action potential, I'm going to talk about the cardiac myocytes and also about the pacemakers. Now I'm going to completely emphasize on cardiac myocytes because we try to understand what the term depolarization and repolarization means. So this is a pictorial representation of the heart. I know it's not perfect. So that's basically your upper part of your heart, which are the right and the left atriums, and then you have the right and the left ventricles, the right and the left ventricles, which are separated here. So I'll just make a bit of a septum here. So that's the thick left ventricle and the thin right ventricle, and that's the interventricular septum. Now what I'm going to do is I'm going to take one piece of a cardiac myocyte from the left ventricle. So I'm just going to cut that off and I'm just going to zoom it so that I can see two adjacent cardiac cells. Okay. So these are the two cardiac cells. This is just a graphical representation. It is not ideally what it looks like. Okay, so these are the two cardiac cells. Now, each cardiac cell, they are the cardiac myocytes. They are called as syncytium. So syncytium means they do have a communication between each other. So the cardiac myocytes are syncytium. So that means they do have a communication between those two cells, and this is this communication between these two cells, which we call it as the gap junctions. So this structure, I call it as a gap junction. So I'll tell you what is the relevance of this in a second. So this is what a gap junction is. So just to repeat again, so you have your right ventricle and your left ventricles, and you have upper part of your heart, which is the right atrium and the left atrium. I'm not going to talk about the blood vessels at this stage. You have your interventricular septum, and the interventricular septum divides your lower part of your heart into left ventricle and the right ventricle. Now I'm taking one portion of the left ventricle to see what's happening inside during a cardiac action potential. So that we try to represent on a graph, which forms the basis of ECG. So I'm taking one cell out, and you can see that there are two cells. So these cells communicate each other, so they are called as syncytium, and they communicate each other by a structure called as a gap junction. Now let's have a look what's happening in one cardiac cycle or one cardiac action potential. What are the events that are happening? So whenever there is a stimulus or stimuli coming to a cardiac myocyte, all our heart cells are on a resting stage. So resting stage, what I mean by a resting stage is, inside the cell or intracellular space, they do have an electronegative potential, and outside is more electropositive. So inside your cell, it is rich in a cation called potassium. So inside your cell is rich in potassium ions. And outside your cell, it is quite rich in sodium ions. Now, if I plot this into a graph, so I'm just going to draw a graph here. Okay, so this is the x-axis. So the x-axis, it represents time, and the y-axis, I'm going to talk about millivolts. Okay. So that means basically we are going to understand the electrical current that is going to happen inside a cardiac cell. So in a resting stage, so inside your cell is rich in potassium. So what happens is, whenever a stimulus comes, it reaches a threshold point. Now what do you mean by threshold? So threshold point means it is a stage where the cardiac muscles are getting activated. Now when the cell is at resting stage, it has been found that the millivolt or the resting membrane potential or the voltage is minus 90 millivolts. So that is where it is resting. It's about minus 90 millivolts. So when there is a stimulus, what happens is your cells start to get excited and it reaches a threshold point. So let's imagine threshold point is about minus 60 millivolts. So what happens is, whenever a stimulus occurs, it is in a resting state, it starts to get excited and it reaches a threshold point. So let's draw a graph like this. Now when I say threshold point, that means it's becoming more electropositive. You know, minus 90 is smaller than minus 60, so it's becoming more electropositive. So this is 0, this is 20, this is 40, and go on. So it reached a threshold point. Okay. Now what happens is, when it reaches the threshold point, so this is very important to understand. There are certain channels here inside the cell which opens. Okay. So it opens certain channels, and these channels, I call it as the sodium channels. So I will say it as INA, or I'll just call it as sodium channels. So what happens is, when the sodium channels suddenly open and they just come into this cell, so just rush into this cell, they just rush into this cell, and as I said, sodium is more electropositive than that of potassium. So if you look onto your electropositivity, sodium is more electropositive than that of potassium. So sudden influx of this sodium ion into these cells can cause a rapid rise of electropositivity. So what happens is, this has reached the threshold point. That means when the stimulus has touched the cell, and then the sodium channels open and it reaches to a rapid threshold point. Rapid threshold point. And at that point, the cells are getting excited. There's a lot of electrical positivity there. And after that, so it suddenly reaches the threshold point of about 30 millivolts, which means the cells are completely excited. It's in an excitation stage. And then what happens is, these sodium channels get closed. The sodium channels get closed. Okay. So the sodium channels, so rapid closure of sodium channels. And what happens is, there will be another channel which opens, which I call it as the potassium channels. So the potassium channels open and it start to leak potassium outside. So there will be a rapid opening of potassium channels, and the cell starts to leak potassium channels. And when the potassium channels leak, the cell start to get more and more electronegative, because potassium is positively charged. When you lose a positive charge inside the cell, it becomes more electronegative. Okay. And after that, what happens is, so your potassium channels have opened. So I'll explain it one more time. So the cell is in resting stage, which is 90 millivolts. It receives a stimulus. It goes into the threshold point, which is minus 60 millivolts. And then what happens is, the fast sodium channels, that means they open rapidly. So there is a rapid open of sodium channels, and there is a rapid influx of sodium ions into the cell, which increases the electropositivity inside the cell, which you have a bit of an excitation. And this is so rapid and short-lived, the sodium channels close abruptly as well. And then what happens is suddenly the potassium channels open and the cell starts to leak potassium into the extracellular space, which goes into a negative deflection. And after that, what happens is, so I'm going to take the stimulus off. You have your calcium ions or calcium ion channels open. So you have a third person here, that is calcium. Now the calcium is a slow opening channel. They're opening very, very slowly when you compare it to potassium and sodium channels. So the cell is still leaking potassium, but at the same time the cell is receiving calcium. Okay, so the cell is leaking potassium, and at the same time the cell is receiving the calcium. So what happens is, at the same time you're losing potassium, at the same time you're receiving calcium. So the net polarity or the net electropositivity will be the same, or we call it as a plateau phase. That means the net electrical current will be the same. So what happens is, it go into a plateau phase. So this plateau phase is a stage where your calcium is coming in and you're losing your potassium. And it is at this stage your action potential starts in and your cardiac muscles start to contract, because inside, when the calcium goes in, inside the muscles there are structures called as sarcoplasmic reticulum, which is correspondence of endoplasmic reticulum, which will help in releasing more and more calcium, which helps in muscular contraction. So the movement of calcium inside and losing of potassium, this at this stage where your cardiac action happens, or the ventricular myocyte starts to contract, and that goes on for some time. And after that, suddenly what happens is, your calcium channel gets closed, and still you will be losing potassium. Okay, so your calcium channel is closed and you will be losing the potassium. And what happens is, so you're still losing potassium and your calcium is completely closed, so the net polarity of the cell starts to go down, as that happened over here. So it's the same incident is happening here, but it goes on for a long time. It goes down and goes down until you reach minus 90 millivolts. So this stage we call it as the repolarization. So repolarization means it is this stage where your cell goes into electronegativity again. And this stage I call it as the depolarization, where your cell is starting to become more positive. So before I stop this, let me just explain this one more time, because it's very important you understand. So this is your heart with the right ventricle and the left ventricle. I'm just taking a piece of left ventricle outside. There are two cells. So these cells are called as syncytium because they communicate each other through a structure called as gap junctions. Now what happens is, whenever there a stimulus occurs, so let me just draw that stimulus one more time. So whenever there is a stimulus, an electrical current or any stimulus occurs, what happens is there will be all the cells are in resting membrane, which is minus 90 millivolts, and it start to gain some positivity, reaching up to the threshold of minus 60 due to the stimulus. Once that stimulus occurs, there will be a rapid opening up of the sodium channel. So inside the cell, so to start with, inside the cell at resting membrane, it is rich in potassium, and outside it is rich in sodium. So what happens is, the sodium channels open, there will be a rapid influx of sodium into the cell, and there will be a rapid stimuli or rapid depolarization. And then at this stage the cells are getting excited, so it's ready to fire or ready to contract. And then what happens is, after the cell is stimulated, the sodium channels rapidly close, because they open suddenly and open closely suddenly. And then what happens is, the potassium ions or the potassium channels will open, and the cells will start to leak potassium, because as I said earlier, inside the cell is potassium is high and outside it's low. So because of the gradient, the potassiums will start to leak through these ion channels, and then the cell will start to lose some positive ions, which is shown as a negative deflection. Okay, and after some time what happens is the slow, so calcium channels, calcium ions will open. The calcium ions are quite slow to open, and this finally they open and the calcium ion starts to come in. So what happens is the number of calcium ions going into the cell will be equivalent to number of potassium channels leaking from the cell. So what happens is, so if two people are going out and two people are coming in, the net energy inside that place is the same. Okay, so that's what happens. So you have two, so the calcium ion is coming in and potassium is going out. It will go into a plateau phase, or a plateau polarity phase, and after some time the calcium ions close, and then the potassium leaking continues until your cell reaches minus 90 millivolts. So at this stage where calcium coming in, we call it as a depolarization phase, and at this stage where you lose your potassium to gain electronegativity, we call it as repolarization. And then what happens is, finally, so those ions, those stimuli which has stimulated the first cell, so this is our first cell, will go through this syncytium or the gap junction, and it stimulates the next cell to cause the same phenomenon again. And that's how the electrical potential move from one cardiac muscle to the next cardiac muscle. This is how the impulses are transmitted. So we're just stepping one step to understand ECG. So this is the basics of ECG, where the cardiac action potential is. Thank you.